Welcome back to the operating system video series, and we saw about the process scheduling, and we have completed all the various scheduling methodologies and the algorithms, and now we are moving towards the synchronization procedures. So when there is a need of process synchronization is when we are moving with more than one process in terms of cooperating process which works in parallel. So there arises the need for the process synchronization, and in order to accomplish this synchronization, we need to look on into what is the critical section problem and how to avoid those critical section problem. Okay, so when the need of synchronization arises, when the process can execute concurrently, and during concurrent execution, one process may interrupt other process during the execution, and this communication has to be performed in a efficient way such that we have to complete the execution of all the process and generate the output. So here we had one issue called as shared data. So the process which are all in cooperation, they will work on a shared data, and we need to provide the data consistency. So this data inconsistency may arise in some scenario due to the cooperation in the execution of the processes. So suppose we'll take a producer consumer issue where the producer start producing the data, and after he produce the data only, the consumer has to consume the data. Unless the producer produces the data, the consumer should not consume the data. So this is a synchronization between the producer and the consumer. So let's take with an example, and here in this particular code, we have a bounded buffer. That means that it may have 5 slots of buffer, 6 slots or 10 slots, whereby a producer can produce maximum of buffer size. So here we maintain a counter. When the counter reaches the buffer size, the producer can't able to produce the data, so it has to do nothing. Once the data is consumed, then the buffer will be emptied one by one. Automatically the producer can produce the data, and the location in the buffer can be computed using the n+1 mod buffer size. Since it has to be go in a circular fashion, after the 5 it has to move towards the again 0. So likewise we are producing the data in the same way. In the consumer side, if the counter equal to 0, that means there is no data in the buffer, so the consumer should not do anything. And whenever the buffer is filled with the data produced by the producer, now the consumer is ready to consume the data, so whereby again the pointer can be incremented using the out pointer. So we have in pointer for the producer and out pointer for the consumer. So this is the way the synchronization must be given between the two processes. Here there is one process called as producer and another process called as a consumer. So these two go on in a cooperative manner in order to produce and consume the data. So here the shared data is the data which is produced. And when we follow this kind of activity in a process synchronization, this may lead to a race condition. Just by maintaining with the here arises a problem called as race condition. By implementing with a counter, this cannot be implemented in a proper way, because due to at some point the incrementation process will left out some of the values which to be maintained between the producer and consumer. So this problem will prevail, and such that we have to form some other solution. So for that we are moving to the next thing called as the critical section problem. So in the critical section problem, whenever the process are working in a shared data, that particular module should be taken as a critical section. So this critical section may consist of the common variables, updating table, or writing the content to a file. So these kind of activities can be taken as a critical section, which should be modified or worked by only single process at a time. So every process should ask permission in order to enter into the critical section, and this arises a competition, and whichever process gains the access, he can get inside the critical section. And after entering into the critical section, after the completion, the process has to come out into the exit section and continue with the remainder section of the execution. And during this time in the exit section, the remaining process which are all waiting for the CPU can compete and gain their entry and work on the critical. So this could be the good solution whereby the shared instances or the shared variables can be operated only by a single process at a time. Thank you.